Let us study what is meant by electromagnetic induction. When a current-carrying conductor is placed in a magnetic field such that the direction of current is perpendicular to the magnetic field, it experiences a force. But if a conductor is moving inside a magnetic field or magnetic field is changing around a fixed conductor, electric current is generated. This was first studied by Michael Faraday. Here, if you had moved south pole of the magnet towards end B of the coil, the deflection would be opposite to the previous case. If both coil and magnet are stationary, there is no deflection in the galvanometer. Thus, the motion of a magnet with respect to the coil, or if coil is moved with respect to the magnet, potential difference is induced, which sets up an induced electric current in the circuit. Here it is seen that if the current in the coil reaches either steady value or zero, the galvanometer connected to coil 2 shows no deflection. Thus, potential difference is induced in the coil 2 whenever the electric current through coil 1 is changing. Coil 1 is called as primary coil and coil 2 is called as secondary coil. As the current in the first coil changes, the magnetic field associated with it also changes. The process by which a changing magnetic field in a conductor induces a current in another conductor is called electromagnetic induction. Fleming's right-hand rule. Stretch the thumb, forefinger and middle finger of the right hand so that they are perpendicular to each other as shown. If the forefinger indicates the direction of the magnetic field and the thumb shows the direction of the motion of conductor, the middle finger will show the direction of induced current. The induced current is found to be the maximum when the direction of motion of the coil is at right angles to the magnetic field. A galvanometer is an instrument which is used to detect the presence of current in a circuit. If the current in a circuit is zero, the galvanometer will show zero deflection or no deflection. The deflection is on either side of the zero mark depending on the direction of the current. Michael Faraday in 1821 found that electricity could produce rotary motion. Today's electric motors are based on this. In 1831, he showed that relative movement between a magnet and a coil of wire would induce electricity in the coil, an idea which gave birth to modern generators. Question. Observe the figure. If the current in the coil A is changed, will some current be induced in the coil B? Explain. Yes, after changing the current in the coil A, current will be induced in coil B. If we switch off the current in coil A, the pointer of galvanometer attached to coil B shows a momentary deflection but on the opposite side. This means that on switching off current in coil A, an electric current is induced in coil B but in a direction opposite to that when the current was switched on. If we keep on switching the current on and off in coil A rapidly, then the galvanometer pointer will keep moving on both the sides of zero mark continuously, showing that a continuous current is induced in coil B. Since the current induced in coil B changes direction continuously, so it is an alternating current. From this, we conclude that whenever the current in coil A is changing, then an electric current is induced in the nearby coil B. Very useful application based on the principle is galvanometer. A galvanometer is an instrument which is used to detect the presence of current in a circuit. If the current in a circuit is zero, the galvanometer will show zero deflection or no deflection. The deflection is on either side of the zero mark depending on the direction of the current. What is meant by direct and alternating current? There are two types of currents. 1. Direct current, DC, and 2. Alternating current, AC. Direct current always flows in one direction, and alternating current reverses its direction periodically. Most of the power stations produce alternating current. In India, the frequency of alternating current is 50 Hz. An important advantage of alternating current over direct current is that electric power can be transmitted over long distances without much loss of energy. Let us compare DC and AC now. First, for DC, magnitude and direction both are constant, whereas for AC, magnitude and direction reverses periodically. Second, DC cannot be used for large-scale electricity for household purpose, whereas AC is used for large-scale applications. Third, frequency of DC is always 0, whereas frequency of AC in India is 50 Hz.